Good afternoon. I'm Wang Kai-hei and he is Chu Ka-leung. We are come from Yuen Merchants Association Secondary School and our registration number is 51111. Our topic is developing 3D human model by using mathematical tools. As we all know, 3D modeling are very common nowadays and have been used in various areas such as game programming and instructional model, etc. Among many types of 3D model, human model is rather common, but it is difficult to make. The techniques included are also very specialized, so we want to simplify the procedure of making 3D human model by mathematics. First, we need to know how to project a 3D object to a surface. In a 3D projection, we define three basic elements: virtual space, object, and observer. And there are three formulas used in rotation. They are rotating the observer location by y-axis, x-axis, and z-axis respectively. For example, we want to change the position of the observer from 00K to 342. There are three ways with different formula combination can be used. Three equations give the same results, but we adapted 1.8 as the method of this is the most commonly used and can be easily understood. This is the test of three formula. We can see that 1.8 is the most common way to change the position of the observer. When we control the position of the observer, 7 steps are needed in calculating algorithm. And this is the comparison of 7-step calculating algorithm using this formula and the initial results. And from this set of simultaneous equations, we can find theta x, theta y, and theta z. And this is the results. After projecting 3D object on a surface, we need to construct curve in a simple way. The most common way of constructing curve is dragging by mouse. By this method, we can simply drag the mouse continuously and the curve will be constructed according to the points. We have 7 methods to construct the curve: elliptic arc, distortion of general function, distortion of circle, amended version of curve C, polynomials, distortion of conic curve, Bezier curve, and circle away. After the comparison of the curve in terms of speed, degrees of average, and rate of change, we have found that curve E and curve F have the best performance and relevant to our research afterwards. Curve E is the distortion of conic curve from the functional curve A of the circle and the transformation of coordinate system. We have found the equation of this curve. And this is the parametric form. Curve F is Bezier curve. This is the parametric formula of the Bezier curve, which can define a curve like this figure. We try to add a value of k so that we can adjust the rate of bending of Bezier curve. And this is the amended version of Bezier curve, which is possible to change the rate of bending. We need to find out which curve is the most suitable curve for us to use. The comparison includes the speed, the degree of average, and rate of change. After the experiment, curve D is the most efficient curve. Length of the line segment of curve E is most similar to each other, and the rate of change of curve E is the largest. The curvature of A and D cannot be changed, and curve E and F perform the best in these 3 tests. So we will only investigate these 2 curves in the future. Besides, we need to prove whether the curve is movable. That means the curve can remain its shape after transformation, and we found that all curves are movable. Also, the position of point E will also affect the appearance of the curve. We have found that when the point is located in the middle, the curve is seem to be more natural and no joining points. In addition, we have found that if we want 2 paths of curves to be smoothly joined, the slope and the curvature of two curves are required to become equal. And we found that found the curvature when the equation of curve is a parametric function. In this test, green line represents the radius of oscillating circle of left part curve. Blue line represents the right part. We found that if the length of two radii equals, the joints of two parts of curve become the most natural. After constructing curve, we have discussed the method of creating curved surface. First, we have only considered 3 vertex curved surface as 2 of them can form a 4 vertex curved surface. We hope the surface created can combine to form a new smooth curved surface. First, each curved surface are defined by 3 vertices x, y, and z, and the definition points of each side are S0, S1, and S2. The formula of definition points can represent by curve f found in chapter 2. Combining this equation, a curved surface formula FTUV has found. This is the curved surface created by curve f. The result Bezier curve. The result is not satisfactory, so we add a control bond G, and this is the result. Besides, we have tried to create a curved surface by curve E, conic curve. By the similar method, a curved surface formula FTUV has been found. And this is the amended version of 3.10, as we found that at a certain value of k, 3.11 will become invalid. And this is the results. That's the end of our research of this part in the report, but we still work on 4 vertex curved surface afterward. This is the formula of 4 vertex curved surface, which is derived from the conic curve. The advantage of 4th vertex curved surface is that it has a relatively even grid size, and the rate of change of the surface is greater. In this chapter, we have found the equation of 3 vertex curved surface, such as 3.7 and 3.10, but we hope that we can amend them to satisfy the following condition. We define 2 surfaces, A and B. If these 2 surfaces are tangent on curve AC, then another curved surface can be smoothly joined on curve AC. However, we are still investigating this problem. Finally, we have tried to create a human model which the pose of the model can be easily changed. By changing the parameter continuously, a series of motion can be formed. We have divided the human motion into 3 types: oscillation, rotation, and free transformation. This is the formula used to describe the relation between the object and the virtual space. We found that it is opposite to the relation between the observer and virtual space we found in chapter 1. Because the motion depends on angles and it depends on time t. To describe the relation, we have used this graph. The user only needs to input the values of the angles at certain instant. The program will generate a curve according to these values, so the model can move sequentially to form a motion. And this is the demonstration of a moving human model. And that's all of our project. Thank you.